This unit we're going to talk about segment lengths. So the first ones we're going to check out are those dealing with chords. If two chords are congruent, then their corresponding arcs are also congruent. So in this example, we have the two chords that are congruent, so their corresponding arcs are also congruent. Another one that we're going to check out is if two chords are congruent, then they are equidistant, meaning equal distant from the center of the circle. So we have these two chords, so this chord and this chord, they are congruent, so therefore they are also equidistant from the center of the circle. And then the last one about chords we're going to check out is if a diameter or radius is perpendicular to a chord, then it is also bisects the chord. So in this example, we have a radius and it is perpendicular to the chord. So it bisects the chord, meaning it breaks it in to two equal pieces. So now we're going to look at a couple examples. So the first one we're going to look at asks us to find the measure of arc MN. So we're trying to find this arc right here. Well, we have here that this chord and this chord are perpendicular to the radius. And this tells us that these two chords are congruent. So that if this arc right here is 103, this arc will also be 103. And since a whole circle equals 360, to find the measure of arc MN, all we have to do is take 360, subtract 103, minus 103, minus 116 to get the arc measure for MN. And we get 38 degrees. Looking at number 2, we're trying to find the measure of arc KLM. So from K to L to M, this is what we're trying to find. And we can see that we have a perpendicular line between these two chords. And so this gives us a rectangle. So these two sides have to be congruent, and these two have to be congruent. So if this side is 38, this side is also 38. And if this side is 142, this side is also 142. So to find KLM, we're just going to add 142 and 38 to get us 180. So the measure of arc KLM is 180 degrees. We have two more of these, and we know that we have a right triangle here, and we know that if a radius bisects a chord or is perpendicular to the chord, then it bisects the chord. So if this side is 6, this side of the chord must also be 6. And then we have this one. We know that if this radius is x, then this radius is also x. So we have a right triangle. So in order to find x, we can use a Pythagorean theorem. X is our hypotenuse, so it's our C value. And then 10.6 and 4.3 will be our A's and B's. It doesn't matter which one's which. So we're going to do A squared plus B squared equals C squared. So A we'll say is 4.3, B is 10.6, and C is X, or you can leave it as C either way. So 4.3 times 4.3 is 18.49. And 10.6 times 10.6 is 112.36. And if we draw our line where the equal sign is, we see that these two values are on the same side of the equation, so we just simply add them. So we're going to add 1849 to 112.36, and we get 130.85. And to get rid of this exponent, we're going to have to square root both sides. And the square root of 130.85 is 11.44. So this is finding segment lengths using properties